VNF manager, sorry. Anyway, so today in particular, we had also talked about onboarding of VNFs and the impact of that. And Eric, in particular, had talked about how Azure Marketplace is already onboarding virtual network functions, and how that is being done in the Azure Marketplace. So today we have a presentation that shows how that is being done, and as well how that then gets uploaded into ONAP. So I believe that that's going to be a very interesting presentation, and then we can see, maybe we can have a discussion after the fact as to, you know, what are the operational function for managing the network function lifecycle, not necessarily the VNF lifecycle, and what else would a VNF package require to do that. So I'll leave the floor to Eric to introduce the presentation.
Sure. So what I'd like to do is just make a few opening comments. And I'm just showing some notes that were passed around from our last meeting, and to give a baseline for what we're going to show in a few minutes. So these are some notes I highlighted in yellow, some of the comments that were attributed to me. And I was thinking about how we're always focused on the Vim or the hypervisor and the underlying Vim as if we really need to worry about that going forward as we deploy virtual network functions and other digital services. And we realize as we start thinking about the PaaS layer, that may not actually be necessary. Some of my other comments down there. And then I made the point that people are already using, virtual network function vendors are already using the Azure Marketplace to build things. And so I was asked to do a presentation on how some of this works. So this led to me creating, if I can find the right slide here. Here we go. This drawing. So you know that you recognize this as our vision of the actualization platform. And so I was thinking if ONAP is sitting like this, that there is this separate onboarding process that occurs by a developer building an NFV, and it's separate from any given operator. But if it's built to a PaaS layer, then we can sort of go through this process, onboard something into a marketplace here, and then later on, someone building a service at the SDC level in ONAP could grab that entity, grab that service, combine it with other things that may exist at that level, and then deploy it onto a cloud platform. And if they use something like Cloudify, it becomes portable across different cloud platforms, and it is easy to configure a service or a service chain, and of course gather telemetry and show a dashboard. But that information goes separately back into this DevOps cycle over on the side here, where we can apply continuous improvement, create new specifications, create a new version of this, and continually improve. So it's this concept that I was thinking I was asked to demonstrate. And what better way to demonstrate it than ask somebody like Cloudify and it turns out Fortinet, you know, to demonstrate how this actually can work. So I'm going to just turn it over, and I'll let the Cloudify folks who were very graciously able to respond to my last-minute request. I'll let them introduce themselves and take over from here. So you can share your screen.
Okay.
Who am I making presenter?
Shai.
Shai. So, hi Shai, you are the presenter now.
Okay. Do you see my screen?
Yeah.
Yes. So actually, Eric, it's a good handover. So basically, we just touched base, you know, beginning of this week. So we got it at the very last minute, and we succeeded to demonstrate, you know, a VNF onboarding on multiple clouds using Cloudify. So basically, the VNF vendor actually has its own life cycle of development. Let's say I actually finishes the development of the VNF and uploaded it to the Azure Marketplace. In the Azure Marketplace, actually, that's the Azure, you can actually look, there are many VNFs already, like the Fortinet that we use, for example, FortiGate or F5 and others. So you have already VNFs here. Basically, after it's in the marketplace, we can consume it. Now you have ONAP. You can actually, in the service design creation, you can specify all the artifacts that you would like to put in the package. Think about SDC as a packager, and it will actually output a package like a Tosca CSAR or an ONAP package to the SO component of ONAP to deploy it. The SO can now go and onboard the different VNFs on multiple clouds. One of them is Azure, using different APIs of different clouds. So if, for example, we look here, we already onboarded using Cloudify a FortiGate VNF on Azure as well as on OpenStack. So if we go here to the virtual machines, we can see that we have a virtual firewall. We defined all the resource groups, all the networking and everything for this firewall. And that's a FortiGate firewall. We can actually go and log into this firewall. Actually, we had some issues with licensing, but Fortinet provided us licenses very quickly, and we actually here use the pay-as-you-go model of Azure, which actually made things much simpler. So if we want, we can go now to the VNF itself and log into the VNF.
So can I ask a question, please?
Sure.
Is that okay, or do you want me to wait for the end of the presentation?
No, you can. Let's have a free format presentation, so
Yes.
you have free to interrupt in the middle.
The only, the question I had was that the package itself. So you said that there was we onboarded the VNF on Azure as well as OpenStack. So as a VNF vendor, does the vendor have to create? In this case, did they have to create different packages? One for Azure and one for OpenStack?
No, actually, it creates. Are you familiar with Tosca?
Yes.
Okay, so Tosca stands for Topology and Orchestration for Cloud Applications. Tosca, actually, you create a CSAR file, which is actually portable. You can now, the orchestrator, let's say Cloudify, can go and deploy the same, the same VNF in multiple clouds, and you specify it once.
Okay. So Cloudify is doing the translation effect.
Yeah, actually Cloudify, and I can show you, for example, here we have an Azure plugin, and in Azure we can actually define, I will go over this quickly because I will show it in the demo, but we can define the Azure resource groups, and we can define later on the availability sets and the VNet, the virtual network, and eventually we actually create the VM itself after we create the subnet, so you can go and see the FortiGate VM here, and it's from type virtual machine. So Tosca as like an object-oriented, it has like a class or node types where you define the nodes. It has node templates where you instantiate the nodes, and you can actually define complex topologies using Tosca. And Tosca is very good to define topologies, hybrid topologies that actually span multiple clouds. Let's see. So basically, we have the firewall here. We actually see the firewall in Azure launched. This is Cloudify. Just one second. This is the Cloudify UI. So basically, we actually use here also some kind of microservices. So first, we have the FortiGate VNF deployment. So we have two deployments, one on actually OpenStack and one on Azure. So you see, we have Azure deployment and OpenStack deployment. On top of it, we actually went with Cloudify and configured a port forwarding or a VPN between the two FortiGate VNFs. So this actually creates the port forwarding on OpenStack, and this creates the port forwarding on Azure. So let's go now to the OpenStack and see the FortiGate. So basically, I can go to the project itself. I'm already inside OpenStack, and I can show you that we created an instance of FortiGate here. Oh, just 1 second. Let me log in.
While you show that, the actualization platform, can it be a non-OpenStack platform as well? For example, Kubernetes or something? Does the definition of
sure. Yeah, sure. Actually, I will go into the presentation and I'll show Cloudify onboard ONAP using Kubernetes as well as on VMs. So Cloudify first. You are familiar with the OOM project of ONAP?
So are you talking about onboarding entire ONAP? Complete
yeah, onboarding entire ONAP, all the ONAP services. Actually, I will jump here to the presentation and show it to you. So Cloudify, actually, I want to go and give a brief, summary of Cloudify. But basically, you have all those ONAP services. So Cloudify actually can first deploy Kubernetes, the master nodes, and then on top of it, deploy the ONAP services. So Cloudify today is part of the OOM project in ONAP. Cloudify is part of the SO for the service orchestration with ARIA there. And Cloudify is also part of the DCAE. So Cloudify onboards all DCAE components for, the KPIs and telemetry, etc. So if I'm looking for a better slide here, just 1 second. Okay, so later on I will touch ONAP and the different components, but I will now continue with the demo here. So basically, we can see the FortiGate instance on OpenStack, and we can actually log into this instance too. So this is the instance on Azure, and this is the instance on OpenStack. Okay, so now in Cloudify, just to explain the process of what we did with Cloudify is, if we go to Cloudify, we have a blueprint catalog. You can define in the catalog many different things. We have the local blueprints that this manager actually has. Blueprint is a definition in Tosca of a topology. Now we are going to deploy this blueprint. So basically, we have a baseline blueprint for Azure and for OpenStack. And on top of it, we can use blueprint composition to define additional services and creation of more complex services to do so. So we actually ran all those blueprints, and you can see that everything is green. It means that everything is up and running, and you can see all the events and everything here, and the different blueprints. And you can see that in FortiGate itself, we created a port forwarding in both sides, both on Azure as well as on OpenStack. So if I will go to the policy and objects here, you can see that here we created a port forwarding. You see here we created a proposed port forwarding, and the same on the other side, on the OpenStack side. Okay, now let me just explain a few things that I think needs more explanation. So basically, if we go back to this picture, so we onboarded the VNFs, we created the service chain, and now we can send back telemetry information, KPIs, to the DCAE component of ONAP, as well as back to the VNF vendor for additional testing. Now let's
I would just add at this point, there's operational metrics that people at the ONAP level want, but there's software performance metrics that Azure development environment provides that provide detailed types of information that allow the VNF vendor to optimize their product going forward. So there's types of metrics that come off the platform in order to fulfill different requirements.
Sure. Yeah, and we can combine the two and manage the two different types of KPIs.
So there are three types of KPIs here, right?
May I have comment?
I was just saying that there are multiple types of KPI, right? One is a host itself and its own KPI, then the VM's KPI, and then the VNF's KPI, right?
Yeah, exactly. Yeah.
Which KPI is delivered by Azure and which by Cloudify? Sorry.
Can you ask again, because I already could hear you?
Sorry, I was just asking which KPI are we referring to? So between Azure and Cloudify.
Okay.
Which
Cloudify provides you all the application KPIs. Let's say you instantiate a VM, put the VNF inside, and now configure the VNF. So let's say there are, let's take for example, complex VNFs with multiple VDUs. So you can actually get all like number of connections, number of sessions, application KPIs. Actually, you can expose anything that you want, because we have a collector that can actually collect any type of KPIs. But I assume in Azure, you can get more information about the Azure cloud itself, utilization, capacity, billing, and all this stuff. And that would come from Azure itself, not from Cloudify.
But how about the 40 manager itself, right? The VNF vendor itself will have its own KPI measurement platform, right? So how would you?
Okay, so what it needs to do is to add those KPIs into the Tosca blueprint, and we will collect those KPIs. We have an open source diamond collector that we can collect those KPIs using different methods and different connectors, and we'll expose those APIs we actually use InfluxDB for time series KPIs. We will expose them into our Influx database that could be consumed by anyone else. In ONAP, it could be in ONAP, yeah, it could be saved everywhere in the DCAE component. Okay, so while we actually push it into the DCAE, you can consume it from the DCAE.
I would also add, there's a GitHub. We use GitHub here to store standard templates that can be, readily reused and updated to provide different types of deployments. But all of these templates end up on GitHub as a sort of an open source repository.
Are there some metrics that are embedded within VNF in order to allow the service provider to track VNF during their life cycle, or there are some agent or virtual probes attached to the VNF?
Yeah, so let's separate the answer into two sub answers. Now, if you have the KPI exposed, we can collect it in any way that you want. Okay, so it's not a technical issue to collect the KPI. Now, it's the term of definition. As a VNF vendor, you have to define, and maybe we should come up with a standard here for all the VNF vendors for, with the VNF onboarding. What are the basic KPIs that are mandatory to expose, and what are the ones that are optional KPIs and mandatory KPIs. But the moment that you expose them and define how you get them, so we can collect them. So it's more a term of a definition rather than the collection itself. Does it answer the question?
Okay, thank you. Yes, it's the same view that I have also as well, from these mandatory ones and optional ones.
Of course, some of that could come from the ONAP definition of what the virtual service collector does, right? So that's another aspect of this that, that doesn't really exist today, but obviously that's one way to collect metrics.
Yeah, and I think in the ONAP SDC component in the service design, that should be in. So you have to, when you create the SDC package, you should actually define what KPIs the VNF vendor should provide. Okay, now,
if you look at the ONAP package itself, right? So there are not just VNFs which are hanging at the bottom of OpenStack, but you would have the app controllers and SDN controllers and all that as well. I mean, if these are also deployed.
I mean here in ONAP actually, if you have the SDC, okay? So you have the design phase. At the design phase, you put all the artifacts here. And in the design phase, you should actually say, hey, I need this KPI to be exposed, and I need it to, to define a policy based on this KPI, for example. So
For all
for
components,
example,
not just VNF, right? Even STN controllers.
yeah, of course.
So I'm a little confused with some of the metric stuff. It looked to me like you're proposing there are not only the service provider, the person who's instantiating the service and recognizing revenue from the subscribers who are using that service, that are collecting metrics to run and charge for the service and operate it and everything else. But you're also showing that the VNF provider, the vendor, the person who created the VNF, may also be pulling metrics directly out of the VNF that gets instantiated in anybody's
No. The VNF vendor just should provide you the capability to collect this KPI. You, as the service provider, can, when you create the service, you can decide whether you want to use it or not. So, but
but there is a hidden question there, and I'm going to answer it. It's a very good question. There will be an option that you probably can control to provide low-level performance of the application itself in production to the creator of the VNF. This is common practice in a DevOps environment, particularly in a shared services environment. It does not, there's no reason to be concerned that it violates privacy or security, but there ought to be an option to provide to the software developer and architect telemetry to that software developer so that they can see how well their things are performing and understand how they should make improvements in the future. And that's fundamental to DevOps and continuous improvement.
And perhaps it's
the VNF packaging and what the experience is from what's the role of the platform, what's the experience from a VNF developer, and then what's the
so basically Cloudify is an orchestrator, and it actually glues all the pieces together and provides you one single pane of glass also to look at things here. So it gets as an input a blueprint or multiple blueprint that you can compose it one on top of the other. It has a blueprint parser and a workflow engine, and basically you can provide to the same blueprint different inputs where you can deploy the same blueprint in different locations, in different staging or production, QA environment, etc. Now, at the deployment itself, it creates a graph. Think about a directed graph with nodes and instances, and it can traverse the graph, and each node instance as a lifecycle operation. Create, start, stop, etc. Now, in Tosca, there are two different primitives actually. So you can define a node, and a node could be connected or depends on another node. Depends mean that it needs to wait till the other node will finish, and then it can continue. So there are some things that can run in parallel. There are some things that run sequentially. And it also has the notion of contained in. For example, you have a container. So now the Tomcat and the Java application are running inside the container. So in Azure, we actually created a virtual machine, but the VNF, the FortiGate, was actually inside the machine. So it's contained in. So that's one concept. Another concept is all the microservices. So we can actually compose a service based on different blueprints. So each blueprint has its own life cycle operations. It can get inputs and send outputs back. And if I already create a microservice that exists, it won't create it again. If I don't want, it just will send me the outputs again. And like this, I have a service proxy that can be relied on multiple separate microservices. So the same concept as microservices. Now, moreover, since we manage everything, the graph in real time, we can deploy on the fly additional microservice, for example, changing the configuration or add VNF to change the service chain. So I have a firewall, I have a router, I can add a DPI in the middle or whatsoever. And now in this presentation, what we actually, I will go here, what we actually did in this example, we use Cloudify to onboard things on Azure here on the right side, and we use it also to onboard it on OpenStack. But we build a composite service, so we had the baseline of the FortiGate, so which has a basic configuration, and then we had a separate blueprint that went to both sides and created the port forwarding or the VPN using a separate blueprint.
It's just as a point of interest, since we got together like on Wednesday or Thursday. You guys put this together like in a couple hours, as near as, just sort of ad hoc, and you were able to actually do all of this within a couple of hours.
Yeah, actually, we had the problem, as I told you, with the pay-as-you-go Azure, but then when we solved it, it took us less than a day to do it. Yeah.
Okay.
Yeah, it was very quickly done. So basically, we have actually a very flexible model, and we have already experience with many telcos. So yeah, that was relatively easy to do. And just a second. Now, I want to go, if we have time, we can go into the blueprints itself and Tosca and the DSL definition. But I want to go now actually to ONAP and to explain, the role of Cloudify in ONAP. Just before that, Cloudify is a model-driven service orchestrator. So it does all the full lifecycle operation here, and with ONAP together, it also does the provisioning as well as the feeding data back into the other ONAP components. And for the first question, you can develop things on Azure, actually. A VNF vendor can go and, where is this slide? Can develop, the whole VNF on Azure, and then try to run it on OpenStack or try to run it on another cloud.
So this is a key point I also wanted to land, was that if you build at this level, and by the way, Cloudify is one example. I picked on Cloudify because they were handy, but it's one example that just illustrates the point that a network function vendor can have a DevOps and onboarding process that's independent of any one operator, but they could develop it on a cloud and then and use it as a DevOps environment to build and test and do continuous improvement. And you can then like an AT&T can deploy right out of that and use it in a customer service scenario. Or you could actually move what was built as a template and deploy it any place else. So there's really no cloud vendor lock-in. It's a hybrid cloud model. I see a lot of articles in the press that I find very misrepresentation of the actual world, that you can use a cloud platform like Azure, build your stuff, and then deploy it anywhere. And then you just pick the best cloud environment, for your cost, performance, and so on, whatever you're optimizing against. But I think that's a very key point that I wanted to make sure was understood coming out of this presentation.
I had a question. I had a question on the cloud. So what happens when a particular VNF requires a VNFM or an EMS for some of the configuration?
Oh, okay. Okay, I'll explain it. Basically, we can work with a generic VNFM or a specific VNFM. With the generic VNFM, it's straightforward. Now, with if I need an EMS, so Cloudify has the concept of core and plugins. So you will write a plugin that, for example, will interact with the EMS using a CLI or REST interface, and this EMS, Cloudify can bring also the EMS, and this EMS will direct the VNF what to do. So we have cases of a generic VNFM and a specific VNFM.
And the generic VNFM would be more in line with what ONAP is providing.
Yeah, sure, because if you want to make it scalable and, if one component fails, bring it, heal it, and scale it, and do all these things. So yeah, you prefer to have something that is standard and not specific. Do you talk about a specific VNFM when you ask the question?
No, just the concept, because I didn't see any reference to any of that in here. So I was just wondering if that's...
Okay.
Thank you.
So basically, Cloudify has the concept of plugins. So we can, as a plugin to OpenStack, a plugin to Azure, to Amazon, etc. You can have plugins to configuration management, to Chef, Puppet, Salt, also to different networking gear like Open Daylight, like any different type of SDN controllers. You can use netconf to interact with network devices. And of course, Cloudify can publish workloads or into any container system. So now if I go to ONAP, actually, so Cloudify onboards ONAP, and it could be on, we are part of the OOM. So if we go here, these are, that's the OOM. Cloudify is part of the OOM to create, to onboard ONAP. Cloudify also onboard parts of ONAP, on VMs like the DCAE, etc. And Cloudify is part of the service orchestrator. So basically, we have the ARIA part, which is Cloudify itself is the full-blown manager, but ARIA is a subcomponent where it has the Tosca parser and an execution engine. So it's Tosca compliant. It supports all the Tosca language, and you can actually define a package. For example, we can go here and see how this is being done. So basically, you can define a virtual infrastructure deployment. It can go either to the Camunda part of SO, and it has different adapters. We actually have an adapter to ARIA, and ARIA can actually go and launch it using the multi-vim on any cloud or any infrastructure that you want, even it's not a cloud. We have cases where we launch it even on KVM using a libvirt plugin. So Cloudify, back to this. So Cloudify, if we can go to there is the Gerrit repo of ONAP. So Cloudify first onboards Kubernetes. Now, if you give it a pointer to an existing running Kubernetes, it will deploy the ONAP services, and I mean all those services. So you have the Kubernetes, and then you have all the 10 different services, the MSO, the message router, SDC, all the ONAP components. So basically after that, that's part of the next releases of ONAP that we will be able to onboard it on any Kubernetes as well as on VMs where you don't want to have Kubernetes. Now, if we go back to this this theme, so after the service is created, so we can send, what we touched, telemetry information back to DCAE. Also, part of the Tosca blueprint, after you onboard the service, you can create special nodes to do test verification of the VNF or even the all end-to-end. So, for example, let's say you define a VCP scenario or another SD-WAN scenario, all the known use cases. So you can create a test verification in Tosca, and you can create some scripts that will actually test that the connectivity is fine. You can test the functionality, and ONAP itself comes with health check of the different components with their robot app vendor actually.
One thing I'd like to just highlight is that in a cloud platform like Azure, you could invoke additional capabilities that each platform provides. So in the case of Azure, you could take advantage of, through intent-based provisioning, make sure that something is properly load balanced, that you can define policies in terms of scale in and out. You could define that it's distributed across multiple data centers or availability zones and things like that. So you would extend, you would take advantage of that through extensions in your template, in your.
Right, but are those requirements defined in a generic way that the VNF can actually identify those requirements in a general way so that they kind of become platform independent, and then they can be supported by mapping to capabilities?
Yeah, that's what I want Cloudify to talk about, because each platform has different capabilities of doing that. So if the NFV vendor has, gee, I want this to be load balanced, I want it to be distributed, there's a way, Cloudify can grab onto those capabilities the way Azure would expect that to be done. And obviously it would have to be done differently if you were looking at a node.
Yeah, that's why it'd be really nice to be able to express those requirements in a general way from the onboarding VNF abstraction perspective, right?
Yeah, exactly.
Yeah, I can tell you that actually I encountered a similar requirement. For example, you need SRIOV or you need to have NUMA. Or, so with the Intel EPA, for example, you can define some specific requirements for that specific VNF. So basically, using Tosca, I think it's easy to express it because that's, in Tosca, for example, we create different types. For example, we have Cloudify Azure Nodes Compute Virtual Machine. In OpenStack, it will be OpenStack. So we can create here, for example, another type that can inherit from the base type, but will add additional capabilities that only this specific cloud has, like Azure. So, and now you also mentioned that you want to be part of the VNF package or the VNF onboarding process. Yeah, so that could be also, good idea to add it to the definition of the onboarding process or the requirement. The VNF vendor could express some manifest requirements that he needs this and this, or he needs this kind of topology, that he needs, for example, if you want to create a connection between two clouds, or you need to have component A or component B and the connection between themselves. And also in Tosca, if we go back here to the Cloudify, so you can, we'll go again. In Tosca, we have relationships. Just let me finish this one thing. So basically, you can see the arrows. So on those relationships, actually, I can run operations, also lifecycle operations. So I can say that if the source and the target, I can ask different questions about the source or the target, or add different kind of functionality as part of the lifecycle of this relationship. So it's easy to express those relationships. And in Tosca, there is another concept of requirements and capabilities. And if we go here, so the VNF vendor, for example, if I have a compute and a database, but the VNF vendor can say, I must have, for example, high-speed connection, or SRIOV, or some CPU pinning or stuff like that, and that could be part of the Tosca definition.
Eric, in deploying in a production environment, do you have some particular agreement with the customers?
Well, you would have to have a completely transparent relationship with your customers so that everybody knows what's going on. But to the extent you accept the fact that Microsoft is a service provider and has many, many vendors giving us, supplying us things as we deliver cloud services and network services all over the world, this is how we operate. This is how we actually operate.
Yeah,
so
sure. That was the question, Eric, right? Because Microsoft probably does, I don't know, 10,000 deployments per day for all we know. But as a user, we never really come to know. And exactly the same concept, can it be replicated using the modeling proposals that Cloudify has by an integrated DevOps model where VNF version there could be 10 deployments, but then it's seamless, really.
Yeah. No, I'm saying it's a process. We have to get there. But it's kind of understood how it needs to work there, and we just have to go through this process of learning how it works and changing, from building monolithic code that happens to run in a VM or a container to a more of a microservices architecture. And all I'm saying is, when you do that, the notion of version control changes in order to keep up with the new methodology. But I'm not saying it's something everybody's blind to. But I am saying that as you move to a true microservices architecture where containers, so you get to the point where you can change the operating system, you can change the software, and you can change hardware without any customer impacting results, that's where you're trying to get to, and there's a process and methodology to do it, and it involves collaboration between the platform, the vendors, and obviously the end user.
Right, and it also entails defining the right level of abstractions to provide the separation of concerns.
Yeah, so it's a process. We're not there yet, but at least we can say the platforms that we're talking about support this or are well down this path.
What do you mean?
Going back,
I just want to say
going back to the concept you were talking about. Go ahead.
Okay, I got it. If I have a critical application, I mean, may I decide to keep a steady version of a particular service instead
of course,
of having?
Of course. It's an option. It's a range of options that are done. It's not some sort of mandate. And in fact, it's this body that's going to help decide how we manage that. I'm just saying from a technology perspective, there's a range of options being offered, including where you deploy it. It's not just one data center. You're deploying it over a geographically dispersed range of options. So you have options. Do you put it in, the big cloud or the edge cloud? And all of these things can be managed, and you're not flying blind. Everybody has to be transparent as what's going on, and a level of trust has to be developed over time.
Okay, so I just want to say, before Dave, just one thing. We are about at the top of the hour. I'll let you comment, and then we have to decide what we're doing. Go ahead, please.
Okay.
Yeah, okay, sorry, I'm in Malaysia, so the delay is a bit severe. Eric, there seem to be two things going on here. One is what I think is in the HIP team, which is once you've got something in the marketplace, instantiating it, running it against a set of templates. But the interesting thing is this item 1 on this slide, which is the bringing it into the marketplace, because in the OLM team, particularly the position that Jenny's been looking at, is a whole set of commercial and, if you like, validation steps have to take place to do that. I'm assuming that's something we can discuss on a later call. Is that?
Yes.
What the experiences are of the Azure marketplace and what mechanisms you've had to put in place in order to create all these options. Because I think the issue that's quite interesting here is that it's not as statically defined. There's only one way of doing this. It's creating a framework in which you can do things differently depending on the actual needs of the particular service you're trying to run. That seems to me to be a pretty interesting part of all of this. Just as a final comment, in the operations center, there has been some work done on joint agile development, which is about how do you integrate the continuous integration and development of one organization with another, specifically a supplier and a service provider, because it's pretty obvious you need more CI/CD kind of process running between the two organizations rather than just purely a traditional static once-off procurement process. You buy this stuff and you that's it. There's some hybrid between those two that's required. I'm guessing that's probably a subject for another call.
I think some of what you're talking about constitute a set of specifications in the DevOps process down there where those green circular arrows are. So we would look for the TM forum or other to decide, hey, what are some of those specifications that relate to manageability and so on, so that process could continue. But the point is, it's abstracted from the operator, and then the operator gets to consume a nearly finished product that, by definition, if it's done at the PaaS layer, is portable across different platforms. So the developer has a place to work and build new product and pursue their business model, and the operator has the advantage of selecting from a wide range of products to construct the services that they're trying to do at their level.
I think what Jenny's been doing is, in fact, this green out of this circle with the arrows, trying to work out what are the, if you like, the essential requirements here. And, it's effectively a minimum viable product which will increment over a period of time. So your point about a set of specifications, what we're doing, I think, is identifying what some of the early ones are. But perhaps we can follow this up on a later call. I think that would be very useful to kind of look at Microsoft's experiences with that and the way that interacts with your marketplace. Because essentially, once it's in the marketplace, it's then available for instantiation. So if it's not in the marketplace, it's not available for instantiation.
And customization, because just because it's in the marketplace doesn't mean it can't be customized. I think Cloudify would agree that they took a very robust Fortinet product and customized it and adapted it to meet their requirement. It's very easy, it just accelerates where you are. It gets 80% of it done. It's usable, but now you are able to work with it.
Yeah, exactly. We took a base. Yeah, we took a base level.
I'll mute while I'm not talking.
Yeah, actually, just to add to it, we took a base level of FortiGate, and then we reconfigure it to to our needs, to the use case that we need to deploy.
But it was Cloudify that put Fortinet onto the Azure Marketplace, or are you just leveraging the fact that Fortinet had put their VNF on Azure Marketplace, and then you're leveraging it from there and then adding to it and things like that?
Yeah, FortiGate was already in the marketplace, but we actually created the VM, created the networks, instantiated the instance of FortiGate. So it was already in the marketplace, yes.
Right. And Eric, is there somebody that you could bring to us and talk about what is Microsoft Azure requiring to for the VNF supplier to put their VNFs on the marketplace? Like I know that
we could certainly do that, and well, of course we could ask some of the vendors that have products up there, like Barracuda and Fortinet, to have that discussion as well. Sometimes the users of things know better than the supplier of things how they work.
Yeah, because
that was where I was going with my earlier question.
Yeah.
That's also where I was going with my earlier question.
Yeah, because it would be interesting more from I know that there's definitely licensing area that they have to provide, so that when you select the VNF, that you know what the licensings are about, and then there's the payment.
Well, that's one thing I want to touch on them as we run out of time here. But one of the points about a marketplace like this is it has a complete set of commercial functions and relationships wrapped around it. So we put this demo together in one day, but Fortinet, when they put it up in the marketplace, they define all of the commercial relationships and how you license it. So if you then have a relationship with the platform through an account, you can grab onto one of these things, and then immediately all of the commercial things are taken care of. And that's a huge thing that gets in the way of agility. But it's a very big value add for a mature marketplace.
Yeah, that's an important point. When I looked at the Barracuda stuff, you can see immediately on the marketplace a statement of the functional capabilities of the product, effectively what the features or the what the options were. And against that, you could also see what the prices and the SLAs were effectively in a single table. And that struck me as being quite important, because you need the equivalent of that in this kind of internal environment, even using it as an internal marketplace, because you've got to be able to know what you've agreed commercially with the supplier, at least from the software asset management point of view, which is where the procurement people are coming from. It's good stuff, this, by the way. But I think I'd be quite interested to hear what the experiences are with onboarding into the marketplace. As you say, Eric, with a couple of suppliers that have done this would be perfect. Perhaps on another call, maybe in a few weeks.